And this is our last chance to ask questions, get things straight, because as soon as we're done with this, we're going to take our test. Woo! And the positive, happy, wonderful news is the test is going to look exactly like practice test 3, which looked exactly like practice test 2, right? So here we go. Number 1, property. What property is in number 1? That is distributive. We should not be struggling with distributive. That is the distributive property. What is B? Yes, it's commutative. Look at the order of the things on the left. It goes 5 and then X and then Y. On the right, it goes X and then Y and then 5. That means that it's commutative. When the order changes, it is commutative, okay? So that is commutative. Very good. What about C? Additive identity. That is the identity. Kids, we've got to keep it straight. When we add and they cancel each other out, that is the inverse. When you add and get the same thing, that is the identity. Okay?
Can you have multiplicative inverse?
They're the same thing for multiplication. If you times by 1, it's the identity, because you get the same thing back again. If they cancel out, it is the inverse. All right, so you gotta pay attention to what's happening. If they're canceling, it's an inverse property. If you're getting the same number back again, so x plus 0 is just x, that is the identity. Okay, 2a, solve. What are you going to do? Use the quadratic formula.
You can complete the square.
You could complete the square. I probably wouldn't, because I'd have to divide by 4, and that would give me an ugly fraction to work with. But I could. It's doable. And you could also try to factor it.
They get factored.
It actually looks like it factors. So if you can tell that it factors and you don't mind factoring, some of you don't like to factor, you could do that.
Why wouldn't you make it 2x and 2x?
Because it doesn't work. I mean, you can try 2x and 2x, but it doesn't work. It won't give you the 27 in the middle. So the answers are -1/4 and 7. Now that was way faster, but a lot of you aren't going to want to try to factor that. And the one on the test might not even factor. So if we use the quadratic formula, go back to the original problem, it would be -b plus or minus the square root of b squared, and I don't happen to know what 27, what is that? 729. Minus 4 times a times c, all over 2a. Now, we're going to want to be careful with that arithmetic in there. Because there's a double negative, I'm actually going to end up adding that, right?
Yeah.
So it's 729 plus. So I got 841. And the square root of 841 is 29. So here come my two answers. I'm going to get 27 plus 29, which is 56. Divided by 8 is 7. So 27 plus 29 divided by 8 is 7. And then 27 minus 29 divided by 8 is -2/8 or -1/4. So notice, with the quadratic formula, I got the same answers as I got by factoring, right? If it factors and you want to factor, go ahead and factor. But they don't all factor, so make sure you have a backup plan. All right. What about the next one?
Oh, I did, I did a number line, and
Yeah.
my answer is -1 in parentheses and 5 in parentheses. Oh, wait, no, in brackets, sorry.
Now, Matthew says he used a number line. Absolutely. Gang, see this right here? That's your clue. That means we're going to use a number line. So in the middle of the number line goes the opposite of the middle number. The middle number is 2 or -2, so I'm going to put a +2 here.
Yep.
I'm going to count forward 3, put a dot. Backward 3, put a dot. The dots are colored. It's less than, so it's shaded in between.
Yep.
And the answer is everything between -1 and 5, which you will write either that way or this way. No other way to write it is acceptable. So if you try to write it a different way, you're going to miss some points. You either write it this way or you write it this way. Either one. Okay, what about C?
So what I did is that,
Multiply by 24 in between the odds. Not sure why we're all so tired. You should have bounded out of bed today thinking, oh, I got 90 minutes of math. Yay! All right, so somebody said we're going to multiply by 24. Now we would do that because 24 will cancel the 8. 24 will cancel the 3. And there's nothing to cancel over there. The whole point is to get rid of your denominators. Right? That's the whole point. So we picked a number 24, and that would take care of both of those denominators. So let's distribute. 9x plus 3 here. And here's where the mistake's going to happen. This next one is -16x minus 8. That's the mistake right there. See that minus sign right there? That distributes all the way through. So that's going to be -16x minus 8. So -7x minus 5. I'm just collecting like terms. I'll add 5 and divide. I got -53/7. Matthew, is that what you got?
yeah.
All right, page 1 done already. All right, page 2. Whoops, got some more solves here. What are you thinking when you look at this problem? Right here, what are we thinking? Number line. I have a couple dots on the number line. I just got to figure out where to put the dots. So what do I need to do? This one I need to factor. Yep. I promise it'll be an easy factoring problem, just like they all have been. So let's see, x minus 5 plus 2. So that tells me where to put the dots. They go at the opposite, right?
Yeah.
So I'm going to have one at -2 and one at 5.
It's greater than 6.
And they're open, and it's greater than, so I see Caitlin going like this, right? Shaded out. So the answer must be written as 2 pieces with an or in between. So we're less than -2, or we're greater than 5. If you wanted to use an notation on that one, you could, but it would be, it's much harder because you gotta have all the infinities and stuff going on. It's easier just to write it this way. All right, what about this one?
Square it.
Square both sides. And this is the one, this is the problem, the one problem on the test where we probably should make sure we check our answer. because when you square both sides, I mean, it's easy. You square both sides, you get x plus 5 equals 36, right?
Yep.
So x equals 31.
Yes.
But this is the kind of problem, when you do that squaring both sides, that's the kind of problem where you sometimes get what we call extraneous roots. So I'm just going to check real quick. Put in 31 for x. Does that work? It takes me like 2 seconds to check it. Does it work? Yeah. So it's good. That's the answer. Moving on.
So what if they?
What?
What if they don't add up with that?
What if it doesn't work? Then you have an extraneous root. You cross it off.
So it's just no solution.
And no solution. Yep. All right. This is a much bigger problem.
You separate the two.
Now, it is not a less than or greater than, so no number line. No number line. Split it in half. So if we look at the first half of the problem, we can take out x squared, leaving us with x minus 2. Very good. Now, how about the second half of the problem? Negative 9, leaving us with, be careful, x
plus 3, x
minus 2.
And then you put the outsides together.
So now we have our common factor,
X squared minus 9.
and left over is x squared minus 9, which itself factors into
X plus 3, X minus 3.
x plus 3, x minus 3, giving me answers of positive 2, positive 2, negative 3, and 3. If that's going to give you trouble, then don't skip the step. There's a step I skipped. That would be x minus 2 equals 0, x plus 3 equals 0, x minus 3 equals 0. When you solve those, you see how you get positive 2, negative 3, and positive 3? That's where they came from. You set them all equal to 0 and solve them. We just normally do that in our head. Jalen?
Is it okay if you just put x equals plus or minus 3?
Yes.
Okay.
All right. A. Let's not miss this, people. Are we going to FOIL this? No! That's a subtraction sign. So we're going to subtract. So we have 4 plus 6i minus 4 minus 7i. The 4's cancel, and all we have left is negative I. It looks like negative 1i. All right, now we're going to do a conjugate problem, I bet. Yep. Do not, no matter what, do not cancel anything. Do not cancel. Instead, you have to actually increase your problem, right? We're going to multiply top and bottom by 2 minus 3i.
Yeah.
And then you get a chance to FOIL on the top and the bottom. So here we go. First, outside, inside, last. And I gotta be careful, sometimes I make mistakes.
I got that.
And then on the bottom, first, outside, inside, last.
Yep.
Now we're going to collect like terms, right? And as we're collecting, let's remember, what is I squared?
-1.
Negative 1. So 6i squared would be negative 6.
Yes.
So I have a 16 and a negative 6.
10.
So I have 10 minus 28i.
Yes.
And then on the bottom, these are gone. Negative 9i squared would be positive 9. So I have 13 on the bottom.
Yes.
Done. What are we gonna do with that? Nothing. Right? All right. Test is half over already. Let's see, number 5. Let's be organized, one step at a time. Let's start with the numbers. I have an 8 over a 28. So that's going to reduce. 8 over 28 will reduce to
7 over 4. Or no,
2 over 7.
7 over 2.
2 over 7.
2 over 7.
2 over
2
7.
over 7. Doesn't 4 go into both of those?
Yeah, that's
So
what
it'd be 2 over 7.
Yes.
Andrew, head up. Look like you're having the time of your life. Woo! Now, what about our x's? Now be careful. They are both negative, right?
Yes.
So they're going to switch places. So I'm actually going to have an x to the 10th on the top and an x to the 5th on the bottom.
Yes.
So you'd end up with
So what's going to happen?
X to the 5th.
X to the 5th on top?
Yes.
Okay, so there's a lot going on with those x's. They actually switch places. So then you have 10 on the top and 5 on the bottom, and you can cancel, and that leaves you 5 on the top, right? Now, what about the y's? Be careful. They're not switching
One's
places.
just going to the bottom.
This one is coming down.
Oh, I love it.
And when we bring 8 of them down, there's already 3 down there, so that gives me a total of 11 on the bottom.
Wait, so why after you have x to the 10th and x to the 5th, why do you bring up x to the 5th?
Think about x to the 10th, Emma. It means 10 x's. And this means 5 x's. So what's going to happen is 5 of them are going to cancel, and you're going to left with 5 extras on the top, right? Anytime you have x's over x's, they're going to cancel. The leftovers are going to be whoever has the bigger most amount. So if the top is 5 bigger, then you're going to have x to the 5th on the top. Equation of the circle is centered at -4, -3 with a radius of root 6. Let's not miss this one. X plus 4 squared
Plus y plus 3.
plus y plus 3 squared
Equals 6.
equals 6. Because when you square r, you get 6. Root 6 times root 6. So it's x minus this number squared plus y minus this number squared equals that number squared. There's no work to show. There's nothing to do except to write the answer. Alright, now we're going to write the equation of a line containing these 2 points. Gotta find the slope. Gotta find the slope. Anytime you're writing the equation of a line, I don't care what you're doing, what class you're in, what problem you've got, you need the slope. So what is the slope of this line?
-3.
4 minus -2 over 6 minus 3. 4 minus -2, 6 minus 3. So that makes 6 over 3. I got 2.
You got 2.
Oh, I was on the wrong problem. My bad. I was on B instead of A. Whoops. That's what I said. -3.
Alright? Now what? You're half done.
You plug in one of your points.
So now you decide how you want to do it. I heard somebody say y equals mx plus b.
Yeah.
That's fine. There's other ways to do it, but that is absolutely fine. We pick one of our points. I'll just pick that one. That's my X, that's my Y, that's my X, that's my Y. So it's gonna be 4 equals 2 times 6 plus B.
Yeah. Equals 12.
So B is -8.
8.
Yeah.
Y equals 2.
Y equals
And
2
my
times-
equation is Y equals 2X minus 8. Remember, in the answer blank goes the equation. Now the next one is exactly the same, gang, exactly, except you're gonna find your slope a little bit differently. It says we want to be perpendicular, which means I need the opposite reciprocal slope of this one. How do I get the slope of this one?
You equal it like.
Rearrange the equation, so y is by itself.
Yeah.
So I'll subtract 3x from both sides. So I'll put a -3x over here. Then I'll divide by -9. So I got 1/3 x minus 4/9.
Yeah.
Now I don't even really care about this part, because the whole reason I did this was to get the slope, right?
Yep.
Which is the m part. It's hooked to the x. So the slope of the line they gave me is 1/3, which means the perpendicular slope will be -3.
Yes.
Yes.
So I'm going to use a slope of -3, and my point is 1, 2. So then can I do exactly what I did over here? Yep. So y equals mx plus b.
Yep.
So I got 5.
Yep.
So my answer is y equals -3x
Plus 5.
plus 5. One more page to go. This is our projectile motion problem. At PLC yesterday, that's our teacher meeting we have in the morning. The pre-cal teachers, we were all talking about chapter P and giving a test and everything. And some of the academic and honors teachers were saying, I don't know, projectile motion's kind of hard. I'm not sure I'm putting it on the first test. I said, what? I said, this is not hard. We got this. So here we go. First question says, write the equation we're going to use for this problem. So read the question and plug in the numbers where they go. Oh, this one's a little bit tricky.
It's coming from ground level, so.
It's coming from ground level. So the initial height is 0,
Which is not.
right? So the other problems we've had, it's been thrown off the top of a building 6 feet tall or something. Well, this one is thrown from ground level, so that number is just going to be a 0. The initial velocity is 100. So you can go ahead and put a +0 there. I'm not going to. I think it confuses things. But that's the equation we're using, right? Easy. Next. How high is the ball after 1 second? So remember, once you have your equation written, with either T's and S's or Y's and X's, it doesn't matter. Once you have it written, you're going to use that equation to answer each question. So, how high is the ball after 1 second? I have to do something with the number 1. I'm going to plug the number 1 in here. Is it going to go for Y or for X? X, because X is the time. So we're going to put a 1 in there. And I got 84 feet, if I did my math right.
Yep.
Yeah, you can.
Okay, make sure you put the feet on there if you wanna get total full credit, we got a unit there. When does the ball hit the ground?
0 for 1.
So we're gonna use exactly the same equation.
Use the quadratic formula for it.
Oh, it's exactly the same equation.
You find out the zeros.
So I want you to listen to something I heard out there in the audience. Well, first of all, when does the ball hit the ground? I'm gonna plug a 0 in for the height, right? Is that right?
Yes.
Now, we've been doing these on our calculator, graphing them, that's how we've been doing them. But I heard somebody say, could we use the quadratic formula? Well, let's think about that for a minute, guys. Could we?
Yes.
Yeah.
Is that a quadratic equation? Yeah. Yeah, absolutely. I don't care. We need an answer. So I'm gonna go ahead and graph it, because that's the way we've been doing it.
I can't find it.
I'm gonna put in the right equation here, so I'm gonna put in the right equation, so negative 16x squared plus 100x. Clear out the rest of that stuff. Alright. Okay, now I zoom 6, so I have a standard window, and I definitely see it crossing the x-axis. Now, I don't see the whole parabola shape, but I don't care. I only need to see where it crosses the x-axis, right? So I'm gonna second calc. And set my bounds. And I got a round number. I got 6.25. So when does it hit the ground? It hits the ground after 6.25 seconds.
Within the quadratic formula, would you just get that answer too?
You would get that answer.
Wait, so when you put that in the graph, would you have to put +0?
No,
Oh, okay.
you can. It won't make a single bit of difference. Not a single bit of difference. All right, 2 more. Anybody who misses these, I don't even know what to say, people. AB stands for what? The distance. So that's going to be a square root. And no matter what calculation we are doing, x's go with x's and y's go with y's. We do not mix them up. So we're going to take x minus x, so -4 minus -2, and square it. That's x minus x, and then y minus y, and square it. Now do the arithmetic carefully. -4 minus -2. Those are going to become pluses, right?
Yes.
So what is that? -4 plus 2. -2 squared, 4. 1 minus 4, -3 squared.
9.
So my answer is the square root of 13. Remember, if you happen to get a radical that reduces, like if you got root 20 or something like that, you have to break it down to get full credit. Root 13 does not break down, so you would just be at root 13. All right, and then how do we do midpoint? Average, very good. That means we're going to add our x's. So -4 plus -2, add them. What's a -4 plus -2?
2.
-4 plus -2 is -6. You're sitting there with a calculator, people. It's sort of embarrassing if you have to use a calculator, but better using it than missing it. -4 plus -2 is -6 divided by 2, -3.
Yes.
And then 1 plus 4, these are my y's, I'm adding my y's. 1 plus 4 is 5, divided by 2 is 5/2. There is your midpoint. Alright, so that didn't even take half an hour, so that's good. Let's do one more problem. Who has something that's troubling you? Then we need to get started on our test. So who's troubled by something?
Business board administration, please.
Is it an emergency?
Yes.
Alright, hurry up. Alright, so we need to do a projectile motion problem? Is that what somebody said, the graphing one? That's the only thing we graph. Okay, so, let's say we're throwing something off the roof, and our initial velocity is 80 feet per second, and the roof is 37 feet tall. So that would be our equation. If our initial velocity is 80 feet per second and the roof is 37 feet tall, that would be the equation that we're going to be using, right? So y equals negative 16x squared plus 80x plus 37. Let's see, when is it on the ground? When is it on the ground? So this is where we put a 0 in for y, because that's the height. So we're on the ground. So I'm going to go ahead and put that equation in my calculator. And I'm just graphing in a standard window. I have no idea what will happen. Remember, what I need to see, what I see is a line coming up here and then coming down over here.
Yep.
Now, there are 2 x-intercepts, zeros. Remember, you can find this one, but it's a waste of time. Because why? What's wrong with this one over here?
Negative.
It's negative. We're not interested in the negative one. What's happening in reality is this, kids. Here's 37. This is the ball, right?
Yep.
The calculator can't read, so it doesn't understand that the building is 37 feet tall. So the calculator is going ahead and finishing the parabola over here. But that doesn't make sense, so we don't need that one. We just need that one. So second calc, 0, remember it's the 0 you're looking for. And your cursor does disappear, but you know exactly where it is because it tells you down here at the bottom where it's at. So I think it hits the ground after about 5.43 seconds.
Yes.
The question says, when is the ball on the ground? At 5.43 seconds. Okay? Now let's finish this problem because you know it's going to be a 2-parter. How high after 2 seconds? Plug a 2 in for the x. So go back to your equation and plug a 2 in for your x. Now, during Flex the other day, we had some people messing this up when they're putting it in the calculator. Make sure that you're doing your order of operations correctly. This is going to be negative 16 times 4. Don't do negative 32 squared. That's wrong. You got to square this first and multiply by 16. So that's negative 64 and 160 and 37. So what does that make? What is it?
133.
130 what?
33.
Feet. 133 feet tall after 2 seconds. Okay? Alright. Alright, so who's going over for extended time? Let me write your pass and get over there. When when you finish, you come back here, okay? Because we'll be moving on. So, who's going to for extended time? Caitlin? And Ron.
So I keep my stuff here since we're coming back.
I know, take it with you in case you don't come back. Are you L-I-N or L-Y-N?
A lion.
Hey, how many is it? 53?
Bang the speaker off the video, we're gonna video test it.
Sure.
Oh my gosh, it's 8:29.